Hey, what's up? So you may be seen this Houdini simulation from my Facebook profile, which I made it a few months ago. Maybe it's 7 to 8 months ago. And after this month, my college exam is over. So I thought, okay, let's revisit this project file and maybe I can share it to my Facebook profile. So you maybe get inspired from it. So let's move into my project file. Okay, this is the project file and you are seeing there is some light and some geometry nodes. So all of those are just render settings, render setup. There is nothing special. The main thing is this geometry node which have the main content. So let's jump into it. Okay, so this is the final result, but what I started with just a circle. So you maybe notice that that power thing is like a oval shape. So what I did here, I transformed the circle to a oval shape like this, and then I resampled it to give it some points to make it dense. And because I need this density, I mean this much of point, because I'm going to animate it with a mountain node. So it's just like this. It have a simple Parlin noise and I gave it a animation. So it's like a solo moving thing, nothing special. But what I did next is the key point of this simulation, because if you uh, because if you notice the main video, you will notice that there is no cut. What I mean this, and look at this. After the video ended here, there is no jump. I mean, this video player is making a jump here, but actually there is no jump. It's just a smooth simulation. If you play this animation in a live wallpaper player, you will see there is no jump. It's just a seamless animation. So I just made the file cache here, so it cached, and then I cut the whole animation from the middle, and then I time shifted it and rearranged it in a way that it have no jump cut. I mean, I took the middle part of the animation and I put it in the beginning, and the beginning part of the animation I put it from the middle to the end. So as a way I skipped the jump from the ending, but now I got a jump from the middle. So what I did, I took this attribute bob, I just took the middle part and this middle part. So I got two frame which have jump and it's in the middle here. So I just gave them a blend, position blend. So I just make them a smooth here. So as you notice, I can't show you this right now because I don't have those cached file now, because I deleted those few months ago, but you got the idea. So after that I got this node here, which is just a curved surface. I just gave those a tube shape which is like this, and this tube is as usual animated because of those path is animated, and this animation is also seamless because the path animation was seamless. So then I gave it a point from volume. So it's just like a simple scattering on the surface but in a volume level. So nothing special. Okay, after getting these points, what I did, just calculated the velocity path in this attribute bob. So what I did, I took this all points position and I subtract it from this center point. So I get a vector which is directing from this position to this position, this position to this position, this position to this position. So which is happening, every point have a vector which is pointing to the center. And then what I did, just a simple math, I took a perpendicular vector which is pointing from center to the y-axis, which is here you can see, and then I cross multiply, I mean, just did a cross multiply from this center pointing vector and that perpendicular vector. And what I got, a vector, a set of new vector which is just circling this center point. Okay, so I can visualize it. So it is this, you maybe notice this, every single thing is just a simple line. This all vector is tangent to the tube. So actually these vectors are circling this center point. Okay, so I render it as a velocity. So every point has now a velocity which is circling this oval shape. Okay, nice. Then the next thing is I gave a noise selection. Now you maybe think why I need a noise selection here. I mean, what I just did, I gave a noise pattern here and I made just white and black. Those are black point. And then I blasted those black point and I got these points. And then I did some attribute blur. I mean, I just clear some attribute which is just the color attribute. I don't need the color attribute again. And then I did a pop net, which is doing here is just animating this point according to the velocity. I already showed you the how to calculate this velocity, and these points are just animating according to the velocity. So it's just a simple point simulation, but I actually need this point simulation for another thing, not for the main simulation. Then I deleted some attribute which is not needed. Then I did attribute blur. So what is the attribute blur doing? It's just calculating the position according to their neighbors, and it's just blurring those points in a way that those are getting close to each other according to their cluster. So that's it. I mean, just for some giving them some looking, and I don't want to make them spreading too much, so I just gave a attribute blur from the proximity, and then I did a file cache. So I already told you I don't need this thing for the actual simulation. I need this thing for other thing. So what I did, I cached them and I took them here in this Pyro solver. So what I did, I just took this volume, I gave some density and v, I mean, which is velocity, for a smoke simulation. Okay, so you are thinking I am doing a particle simulation, so why I need a smoke simulation? Actually, I need a smoke simulation. So I will tell you why I need actual a smoke simulation. So let's see the smoke simulation. Okay, this is the smoke simulation. Okay, I'm doing it, but you can't see the smoke well. So what is happening here, I don't know, because the smoke turned out black. I don't know, maybe it's a version mismatching thing, because this project file was made in another Houdini version. So okay, let me make this light background. Okay, now you can see this smoke. It's not very visible, uh, I have to troubleshoot it, but for now you can see the smoke here. So this is the smoke. This is not very visible, but this smoke is actually very dense. It's not that much light what you are seeing here. This smoke is actually very dense. Okay, so I took the smoke and then I file cached it, and then I did a volume analysis. So what is happening here in the volume analysis? I just took the density and I calculate the gradient from the density. So what I did, I took the density from the gradient. I mean, I took the gradient which is calculated here, and I, according to the gradient, I did a pop advection. Here you can see it. Okay, it's cooking. Give it some time. Okay, you are seeing this is the thing. Okay, let me turn it to the dark. Okay, so I did a pop advection from the smoke. So let's go. Okay, and just I advected these points according to the smoke from the smoke. So this all points was just advected by the volume, and then I did a density advection. So this density advection is doing a special tricks. You may notice there is some stringy particle trail. This is going like that. This is this. This is this. So it's like a energy trail, which you've seen in animal kind of thing. So these are not possible without the density advection. So when you will do a volume advection, you will just see those particles are moving according to the smoke and not doing this string kind of thing. They are just spreaded in a even way, not in a cloudy way like this, and that's why you need a density advection, and this actually based on the gradient. So how I get the gradient? I get the gradient from here. I mean from here. I did just a volume analysis. Okay. So then I, as usual, cast the whole simulation, and then there is nothing special. I just gave it a color, what you seen, and then in the middle section, in the actual tube area, where was the tube, you may see there is some emptiness. It's not actually aligning with something. So I just did nothing. I took the previous this thing which helped me to do the pyro simulation, and then I just merge it here. Before merging I gave it some color, and then I merged it with the main simulation. So for the merging, you will see there is something in the middle, it's not empty. Okay, so now it's going somewhere. We got the simulation, and now this is the tricks, another tricks. What do you think, which is this doing, these nodes? So what I did here is the same thing what I did here. It's just you can't I mean I don't know is there another system or another way, but I figure out that what you have in Houdini, if it's not a seamless animation or seamless simulation, you just cast it the whole length of the simulation. In this case, this is 240 frame, so I cast the whole simulation here, and then I time shifted this simulation. So it's actually the same thing. I cut the simulation from the middle, and then I put the ending part at the front and the front part to the middle. So what I have now, a seamless transition in the ending and the starting, but I got a jump in the middle. So how to fix the jump? It's nothing. You just have to make a attribute bob, and you have to merge the two part of the simulation in a way that there is no jump. So it's kind of fade way. Okay, I will show you in a graphical way later, but for now this 4 node is just for the seamless transition and nothing. And then we got this thing. I just make it a small according to my character size, and then I imported my character. So this is my character animation. By the way, I got this character from a game which is called Genless Zone Zero. It is a gotcha game, and I got this character. So what I did, I blast the whole character, and I took one point from the character, a single point, and this point is from the character's torso. So why I need this point? Because if you notice the character, if you see the character animation, okay, I'm going to play it. Okay, so this character is floating in the space, and it have some up and down animation. Okay, so the whole character is going up and going down and going up and going down. So the simulation have to also go up and go down to match the animation. Okay, so that's the thing. So I took the point from the character torso, and then what I did, this point was going too much up and too much down, or matching with the character, but I don't need that much movement. So what I did, I took this attribute verb, and I just multiplied y movement by 0.5. So this point is now little bit slow moving in the y direction. Okay, so it's nothing. Then I transform it little bit lower, and then I copy to point my whole simulation according to the floating point. So now if you notice the whole simulation. Okay, by the way, if you are thinking why this simulation is not at the full rate in the beginning, because I already told you I don't have those file cache. Okay, I deleted those, so that's why I don't have now seamlessness here. Okay, so I just put the simulation on the point, and then I transformed it according to my camera, and then I transformed it again. So it's just nothing. Then I multiply the velocity. I mean, you notice that I didn't deleted the calculated velocity from the beginning. The velocity is always with those position. Okay, so I have those velocity attribute, and I just made them little bit bigger here. I don't need this velocity for another simulation. I just need them for a trail simulation. Okay, so what I did here, I did multiply the velocity. So which velocity? I got this velocity from here, from the beginning, where I calculated the velocity from here. Okay. I didn't delete those velocity in this attribute delete. So why I need those velocity? Because I need motion blur for the render. Okay. So that motion blur is essential because if you don't motion blur your simulation, you will notice the individual point is floating, and your simulation is stuttering. It's not a smooth simulation. So because for that I did a motion blur, I need a motion blur, and that's why I multiply that velocity. Because for the motion blur I need a strong velocity field, so I just multiplied it by 10 to get a strong velocity field, and then I out it. And yeah, I did a trail here to just for the motion blur. Okay, and nothing. So that's how we got the final simulation. Okay, so this is the thing. It's going and it's going. So you got it. This is the main simulation, and after that there is some render setup. There is some render setup, which is this glitter. So what is this glitter? You may notice there is some star. So I did a nebula type of vibe here. So there is some star kind of thing floating. If I play this simulation, yeah, you noticed that there is some star floating here and there. So how I made those star? I took the main simulation and I took it here. It is looking little bit complex, but it's nothing. So what I did here, I took the main simulation and then I did a point delete thing. You may notice I removed all those point, and I just randomly selected some point here and I keep those point. Then I did another remove point thing, and I then deleted all the attribute from the previous simulation, and then I added color on the points according to the main simulation. And exactly this is actually this and these are the same setup. So I took two set of glitters and I merged those glitters. So one set of glitter color is according to the main simulation, and the other set of glitters has kind of golden color, and I merged those thing, and I did a p scale, set p scale. I gave them some noise, and I just gave it a normal attribute. Then I gave them a velocity. Okay, and this is another line of notes. What I did, I took a circle here, then I did a loop. Okay, so what is this loop doing? In this loop I added a mountain node, and this mountain node is working on the points, but you notice there is no noise on the y direction. Okay, this noise is just in the points. Then I remeshed it, then I did some y direction noise, and I packed all those noise. Okay, so why I need this loop? I need this loop because I needed this kind of shape, few of them, not one. Okay, because I want to scatter these shapes on the points in this cloud. Okay, in this glitter points. So I did a loop, and this loop is doing 10 of those shapes in a different way. Okay, it's nothing. If you are familiar with Houdini, you can discover it. And then I did a copy to point, and notice these shapes are now scattered on those point. Okay, and these all shapes have random rotation, random scale, and etc. etc. That's nothing. And then I gave them a material because I want them metal kind of polish, not a roughness. And then I render out that. So you notice there is this geometry node. It's just a max of glitter. I mean, I need AOVs for render because I rendered all those parts separated. This character is render separated, these glitters are render separated, and the main simulation was rendered separated. So for the sake of AOVs, I did some max thing. Okay, I maxed the this part of the glitter by this character in this geometry node. Then I set a camera here, and then there is eye render. So why you may think why I need this eye render geometry? It's just nothing. It's just the character eye and nothing. So I render this character eye separately. Now you may ask why I render this character eye separately. Because I render this character eye separately, the cause is when I render the character, I notice that my character's eye are not well illuminated. Okay, it was too much dark, and as a anime character it should be more illuminated eye. So to get those illuminated eye, I render those eyes separately, and then I color graded those eye with a bright light and nothing else. And this is my main character render. And now you think why I need this much of light. And again, my power simulation has illumination. It those have illumination themselves. They are emitting light. So why I need these lights? Because I need these lights because this simulation is having some illumination, but those illumination are not enough to illuminate this character. You are noticing this character is now blasted with the lights, but actually in the render these lights are not that bright. So you may notice it's a circle light, and this light is illuminating the character face. Then there is a torus shape of light. Yeah, this is the torus, and this light is illuminating this character. According to the main simulation, this torus is have two kind of light. So one light is blue and one light is red. Okay, let me show you. Yeah, so you may notice this torus is two part light. This part of the torus is emitting red light, and this part of the torus is emitting blue light, and that's it. So that's why in the final render my character have blue light from this direction. You may notice there is some illuminating reflection and there is some red reflection. This red reflection is coming from this side of the torus and nothing. That here you may notice there is some red reflection, there is some red reflection under the shoe, there is some red reflection, and on the top side of the character there is blue light reflection. So those two lights are coming from these two torus. So it's just according to your taste, uh, which kind of light you needed, but I set it those lights in these ways and nothing else. So yeah, this is the whole project. So this is not a complete breakdown, it's just a overall showdown to give you an idea how this kind of simulation is made. So for the beginners you may think, oh my god, this is too much complex thing, I can't do it, I can just make a simple fire simulation. But actually this kind of power simulation is not that complex. I mean, you can get a plenty of simulation just by doing some simple things. Okay, I admit that my project has some complexity because I gave it a seamless transition. But if you escape this seamless transition thing, you will make some cool power simulation just by doing some few works in the Houdini. You don't need all those complex parts. And yeah, again, these all things are just for the AOVs and render. Those are not for the main simulation. Yeah, so I just have to polish this render. And yeah, I did this compositing in nuke, so that's why I have those light reflection in the lens. But actually those reflection are not from the Houdini, those are just compositing in the nuke, and that's it. So this was my first voiceover video, and I don't know, I think my English is not that good and I'm not good at explaining thing. But yeah, I did it, and maybe later I will did more videos like this. So yeah, keep eye on my Facebook profile or in my YouTube channel. I don't know where I uploaded, but yeah, I made my mind I will did some voiceover videos in the next. So see you later.